see what you're not saying with target too.
All right. So here's an example. So let's say I have a graph, and this could actually be, and you can think of this as an actual path something could take. So position in feet and time in seconds. So if I'm at position 2 to start with, and then 3 seconds later I'm in position 3. That's good, Jeff. I like that. Let's say 3, 4. That's awesome. All right, let's say I'm at position 3 times 0. So I'm 3 feet away from something. And then I start walking away from it, right? I'm like, let me just walk slowly, some kind of a bear. And like, if I run, it's going to chase me. Walk, maybe I'll fall over and play dead. I don't know. We don't need to know any of that. So I'm 3 feet at 0 seconds. 3 seconds later, I'm at 4 feet. So at 0 seconds, I'm at 3 feet. Before somebody started, like the bear took out a stopwatch and started recording. It's like, this is interesting. Let me do this before I eat this human. And then at 3 seconds, I'm at 4 feet. So what's my rate of movement? How quickly am I moving? This is exactly like some of the problems we did the other day. Yeah, so how quickly am I moving? So what would that be? What units would we naturally use? Not seconds per foot. We use feet per second. Well, it's just like miles per hour. So what did I say? What's normally going to be on the bottom when it involves time? Time. Time will almost always be on the bottom for rate. So many things per minute, so many things per year, blah, blah, blah. Okay? So what was the change in position? 4 minus 3. So I went 1 foot in how many seconds? Yeah, in 3 seconds. So my rate of movement, you can take this one more thing, you can say 1/3 of a foot per second. So every second I move 1/3 of a foot. Let me stop here for a second. You see how that's exactly like what we did in section 3.4? This is actually getting into section 3.5 a bit. This is the idea of slope. How much did I go up on this scale? 1. And then how much did I go over
3.
to get to the next point? 3. Up 1 over 3. So let me give you another physical example. Say there's steps to a door, right? And nowadays you better also put what that leads to that door? Thankfully. So you have a door here, and there's steps that leads to the door. That better not be the only way to get there, especially if it's a government building. What else do you have to be able to? A ramp, right? For those of us who can't get up there on steps. So I got to also have a ramp. So now watch. Which one of those should have a smaller slope? So when I say slope, what do you think of in the real world?
Hill.
A hill, right? You're going to go up on the slopes. I'm going to go up on the slopes. I'm going to ski. Snowboarding's better. So slope means in mathematics the same thing it does for us. If something has a big slope, that means it's really steep, right? Does that make sense? So that idea of what it is physically, beautifully enough, is the exact same idea as it is in math. There's just going to be some computations with it. We're going to be more precise. So which one of these should have a steeper slope? The stairs. Because what's the reason for this? Is to make the slope more gentle. Sort of like if you ever hiked Cowles Mountain or Coles Mountain, depending on how you feel. There's these things called switchbacks. right? Instead of just going straight up the hill, which would be really steep, which some people want to do, but stop doing that shit. You're destroying the environment. Setbacks they make it less steep, so you get up the hill. I love it. So let's say that in the time it took to go, I go up 3 feet and over 3 feet. So as you climb stairs, aren't you going up? But you're also going forward. All right, beautiful. So in the time it takes me to go up 3 feet, I went over 3 feet. So what would the slope of these stairs be? The slope would be the rise over the run. This is what makes sense physically. How much did I rise divided by how much did I run? So if I rise a lot and run very little, that's steep as all shit, right? If I'm looking at it as like this, that is steep. That means it rises a lot and runs a little. And won't this become a really big number if it's big on top, small on the bottom? So this makes physical sense. So how much do I rise? Well, I rise and I run 3 feet each. So what's the slope? 1. So whatever this number is, it should be smaller than that. It's supposed to be a gentler slope. So let's say that both of them have to get up 3 feet because that's where the freaking door is, right? But if that's 3, this looks like maybe it's 8. So what would this guy's slope be? Rise over run. 3 over 8. 3/8 is a lot smaller than 1. It's gentler. I love that shit. The exact same way we think about slope in the real world is the way we think about slope in mathematics. It does have more technical. We can say, that's a gentle slope and that's a rough slope. No, in math, I'm going to have to say that's the slope of 3/8, it's the slope of 1. Have you guys, you've been driving around enough that you've seen like 7% grade signs? I've seen once 11% grade somewhere. I mean, what the shit does that mean? Does that mean that somebody's keeping track of how well you're driving, that 7% of your overall grade determines if you're going to go to heaven or hell? Well, you almost made it. But just one time? No. What does 7% grade mean? Everybody know? What is slope again? Rise over run. And 7% is what fraction? 100. So that would mean a 7% grade means if you're going up it, you go up 7 feet as you go over 100 feet. Now that doesn't sound like, ooh, but 7% grade is decent. That's where you start seeing those runaway truck ramps. And the first time I saw that, I grew up in Florida. The ground goes down for sinkholes. It didn't go up. So I drove out to Colorado, and I was like, holy shit. And then I saw a runaway truck ramp. I was like, okay. So that's when you start seeing that. 7 over 100 means if you're traveling decently fast, you are going down or up very fast. Right? This doesn't seem like much, but over the course of how quickly you're traveling, you are dropping or rising very quickly for 7% grade. So for every 7 feet, so if I'm going up, for every 7 feet over, let's make it even, you can kind of see this. For every, 7 feet up, I go 100 feet over. So that would be this kind of a hill. Now, normal street would be 0 slope. I'm not going up or down at all. Right? It's something close to 0. And then if you drive around Mission Hills or that one thing going to the airport down Laurel, I think it is, right? Or no, there's even a, anyway, I can't remember. We'd always take my kids and we would stop at the, everybody ready? Here we go! And they're like, yes! It's cheaper for, they need a box and a slope, and they're great. Anyway, so now you understand what the hell that percent grade thing means. It's slope. Because percent is a fraction. Slopes are fractions, they're ratios. Feel like it. So, let's take this all the way math. Oh, shit. Let's take this all the way to math. I don't even know what they're talking about in the book. We'll look in the green book in a minute. So straight up math, look at this. So if I have 2 points, exciting. All right, so let's say I have the point, this point here, and that point there. So this point looks to be, yeah, -3,
-2.
-2, and this point looks to be 1, 4. I like it. So if they give you the graph, I could look at it physically. What slope again? Rise over run. So how do I get from one point to the other? How much do I rise to get to that point? 1, 2, 3, 4, 5, 6, it looks like. Right? Is that decent? In fact, what's up and down? Which variable controls up and down? Y. What's the Y here?
-2.
What's the Y there?
4.
How much did Y change by? It got 6 bigger. Oh, shit. So that's why the rise is the change in Y's. You got to appreciate when it rhymes in math. Right? Rise is the change in the Y's. Why? Because Y is freaking up and down. That's why. Sorry. So this would be, so far we got 6 up, and how much do I run? 1, 2, 3, 4. And again, what controls left and right? And the X started at -3, went to 1, so it got 4 bigger. I just counted off 4. So what's this guy's slope? 3/2. I like it. Now watch, real quick. That means that if this was sitting on a line, oh my God, that's really good. Holy shit. All right. Watch what happens if I go, now see, it's up 6 over 4. We just reduced that though, didn't we? Yeah. So look what happens if I go up 3, 1, 2, 3, over 2, 1, 2, there. I'm on the line again. What if I went up 30 over 20? I'd be on the line again. Big steps, small steps, it gets me back to the line. So what's the slope? Physically, it's the same as the slope in math. That's awesome. Also, the slope tells you if you start on the line, here's how you get back to the line. If you're on the line and you do this, go up 3 over 2, you're back to the line. And anything that is 3/2, like 6/4. What else is 3/2? Multiply by 5, 15/10. If I went up 15 over 10, I'm back on the line. It's kind of like a direction to go. All right, maybe. Okay. So, to make this a little more formal, what if I had just a general 2 points? Just sitting on this plane, I've got one point is x1, y1, and the other point is x2, y2. I love this shit. So now we're going to make the formula so I don't have to graph the damn thing every time. It is all about difference in y's and difference in x's. So how much do I change, do I fall or run would be the difference in the y's, because y is up and down. So this should sound very familiar to everybody. This is going to be y2 minus y1. That's how much I changed my up and down position. And then how much do I change my left and right position will be x2 minus x1. So there is a very important equation. Make that a definite x. Hopefully this looks familiar. y2 minus y1 over x2 minus x1. Rise over, I always used to say y's over the other guys. Rise over 1. You know, and x doesn't rhyme with run, but oh well, shit. So let's try a couple problems. You don't have to graph these. In fact, do not graph these. If they give you a graph, count. Sweet. Up, over, down, back. Right? Real quick, before I go too far. What if I started at this point? How do I get to that point? I go down how much? I go down 6, right? And I would go back 4. Down 6, back 4. Does it come out to be the same thing? Try again. What do the negatives do? Cancel. 6/4, 3/2, same thing. Right? So if I said, how do I get from my house to your house? All right, you go up 3 blocks, over 2 blocks. How do I get back home? You're like, you just go back 3 blocks, back 2 blocks. I mean, so I should, if I can get from here to there, I should be able to get from there to back. But it doesn't change the slope. The slope is the same. The slope is 3 halves. All right, so watch it. So let's try this out. Find the slope between these points. Let's try this one together. I really want you to understand why we have the little subscripts on this equation. So the equation is y2 minus y1 over x2 minus x1. So I'm going to do this 2 different ways. What does that little 2 and little 1 subscript mean? Yeah, how many points are up there?
4. I mean 2.
2. So the 2's reference the xy's from the second point. Well, which one is the second point? Well, I wrote that second, but couldn't I have written this second? So watch, I'll do it 2 different ways. If you need to, you can label these suckers. X1, Y1. Pick something to be the first point. Then this guy's got to be the second point. And then just plug and chug. So the subscripts are there just to keep me subtracting in the same order so I don't mess the sign up. Why does it make sense this slope is positive? Because this thing is going up. So if it's going down, the slope would be negative. It's crazy. So if I do it this way, I get 4 minus 6. Is that cool? Y2 minus Y1 over
-3.
-3
Minus -1.
minus -1. Good. Don't get overly and say, I already wrote a negative. No, you didn't. You wrote a minus, and then it's a -1. So what's this come out to be?
-2.
-2 over -3 plus 1, right? Which is -2 over -2, which is 1. Okay, now what if somebody else sitting next to you had decided instead to call this x2, y2, and this one x1, y1? It's fine. Some of you guys might realize it's going to change the sign of both, which ends up canceling anyway, just like it did on this one. So this would be, that would be 6 minus 4 over -1 minus -3, which is plus 3. Is that cool? So you would get 2 over 2, you get 1, the same damn answer we got up there. So that's related to going up and over or down and back, it doesn't matter. That's the relationship. You see how, did I graph anything to do that? No. So that's a straight up algebraic way of getting the slope. You don't have to graph them. If they graph it for you, sweet. Rise, run, sweet. If they don't graph it, don't graph it. Just use that algebraic formula. So you guys try these 2. Find the slope between these points. So what do you guys get up here? What do you guys do?
6 minus 5.
Okay, 6 minus 5 over.
Negative 1 minus 4.
So if you do this minus this, you have to do this minus this. That's really what the subscripts are saying. So it doesn't matter if you haven't turned around, you end up at negative 1/5, right?
Oh crap, I was the wrong one.
It's a great time to make mistakes, because they don't count against you yet. All right, what about this guy? So you'd write
Negative 2 minus negative 2.
negative 2 minus negative 2 over,
5 minus.
sure, 5 minus 6 or 6 minus 5, whichever way you went. Yes, sir.
So is the y's always on the bottom or x always on the top?
See up here, look, 6 and 5, those are y's, right? What's on top? Rise. And that rhymes with y's. You gotta love that shit. Y's on the top, x is on the bottom. Okay. So what do you get here? Yeah, you get 0 over who gives a shit. What the hell would that mean? If you now you don't have to graph these, but let's just look at the graph just to make sense of this. Yes.
I just changed it to positive.
Say again?
Negative. I changed it to positive.
Yes, totally did. Of course I did, because that's how that works, right? What's negative times negative?
Positive.
Positive.
The slope would be
No, careful. No. 0 divided by something is 0. Right? I think there's something, I can't remember exactly, but I think there's something like this. Right? Numerator over 0, no. That's undefined. 0 divided by something is okay. Because again, if I have no money and there are 8 of us, how much money does each of us get?
No.
None. Right? In fact, how do I check this? 0 times 8 is 0. Now look at this one. What if I had $7? I have $7. And there are none of us, including me. I'm not there. Oh, what the fuck? All right, that's weird. But a better way to look at it is, what number do I put here so that when I multiply it by the bottom, I get the top? That's what it means, doesn't it? 6 divided by 2 is? 3, because 3 times 2 is 6. That's how division works, is how you kind of check it with the opposite operation. What number times 0 is 7?
Nothing.
What do you always get when you multiply by 0?
Nothing.
So what number is defined in such a way that when I multiply by 0, I get 7? Ain't no such thing. So what do we call it? Undefined. Because there's no number defined to do that shit. Right? So division by 0, you make black holes and everything gets sucked in there, and don't do that. It's all fun and games until you make a black hole. 0 divided by something all day long is fine. 0, 0 screws us up, but it's still a number. It's an acceptable number. Doesn't mean no solution. It doesn't mean any of that shit. It just means it's 0. So what is it, if the slope is 0, what should that mean? If I said the slope of this is 0, that means it should be
No line, right?
flat. 0 slope should mean flat, right? When you put the level on it, it's going to be all gnashing in the centers, water bubbles. Right? So what would this look like if I graphed it? It would be 1, 2, 3, 4, 5, 6. 5, negative 2. 6, negative 2. There, does that look flat? Yes. From between those 2 points, that is flat. So it makes sense the answer is 0. I like it. Yes?
For b then, if you got 5 over negative 1, would that be negative 5?
If, yes, if, sure, if. We definitely didn't, though, right? Is that cool? But if I had turned the points around, then we would have gotten 5 over negative 1, which is negative 5. Yeah. All right, how we doing? Everybody decent so far? Okay. Let's look at the Green Book before I get too far. It's kind of, Green Book is nice because it keeps me organized. Can somebody do that middle light. Cool, thank you. Okay, so if you have this is page 26. So this kind of reiterates some of what we already discussed. The slope is rise of a run. Now, some of you guys, I don't think I've written M yet, have I? Yeah, I did. Do you know why it's M? It's kind of funny to me why it's M. It's a French word for walk. The French word for walk is marcher, like march. So they were like, what language should we use? Let's use French to pick a letter. Yeah. So that's why it's M. It's not like the mope. Why didn't they use S? I wasn't around, sorry. Alright, so they just picked M, marche, what the shit, why not? They're trying to get in good with the French at that time. Oops. So rise over run, that's the physical interpretation. Mathematically, that's the change in the y's, changing the x's. Y2 minus y1, x2 minus x1. You got to know that. I would think that many of you should already kind of know that. The rest of you need to commit that to memory. You should have that sucker. So here, real quick. They give you a graph. Find the slope of this line for me. Don't say anything out loud. Just take a second, a couple seconds. Figure out the slope of this line right here. Even before you do anything specific, is it going to be positive or negative? It's going to be negative all day long. Is this a good thing for a profit picture? Like, let me show you how a profit's working. Oh, shit. This is bad. We need to go back in time, and then we're fine. So again, you pick any point you want to that you can see. It doesn't matter what point you pick, and it doesn't matter what point you go to, because it will reduce to the same thing that kicks ass. If it's a straight line, that will always happen. So if I choose this one, and I want to go to this one, that kind of makes sense. How much do I rise? I actually fall.
Negative.
So that's negative. Yeah, so I'm going to have to go down 4 over positive 4. I like it. So down is negative, of course. Back would be negative. But I went down 4, negative 4, over 4, positive 4. So, of course, that slope is?
Negative 1.
Negative 1. I like it. Why am I getting so washed out? Okay, good. Whatever sound effects you want. Now, real quick, if you would have picked these two, or something, it doesn't matter, and went up and over, I would go up how much? 3. I like it. So up 3, back 3. So negative 3. What is 3 divided by negative 3? Still flipping negative 1. What if I picked this point and that point, and it would have just been double, right? Actually, not double, but watch. How much do I go up? 7. And then I go back 7. 7 divided by negative 7 is still negative 1. I like it. So since a line's slope never changes, that's almost the definition of a line, is the slope doesn't change. It doesn't matter what the hell points I pick. They'll all work out to the same thing at the end. They have to. It's the same stupid line. It never changes. How are we doing so far? Is that? Okay. I'll do this one real quick. Let's see, do it geometrically and then check it algebraically. Geometrically means just counting. Rise over run. Algebraically is that crazy ass little formula. You should get the same plus you. Same result both ways. Oh yeah. All right, let's see. So geometrically, again, it doesn't matter which points you choose. If I choose these two, I have to go up 1, 2, 3. I have to go over 1. And I could tell it's a positive. Don't give me a negative number when it's going up. That should be a red flag to you, right? Which is, well, that's what I got. That's what it must be. No, it's up. It's good. So no matter what points you picked, you should have gotten 3. Now, if I take those same points, what point is this? 2, 4. And what point is this? 1, 1. I like it. So then I use the algebraic way. I could do 4 minus 1. That's the change in the y's. Over 2 minus 1. The change in the x's. And I still get 3, of course. It's got to come out to be the same thing. Because this equation is built off of this geometric interpretation. Sweet. How's everybody doing? Now, I know some of you guys are like really good at graphing. That's awesome. Just enjoy it while you can. Some of us are like, I don't remember graphing at all. So this is the time to ask questions, right? I don't know if I've said this before, but everybody has such a drastically different background mathematically in this room. Don't give a shit about people around you that are like, oh, this is easy, whatever, right? They've taken higher math in this before. Good for them. You focus on, do you understand this? Is everybody cool with this? That was a good time. Okay. All right. So let's try this one. Let's get freaking. Next page, 3b. It says to find the slope and then graph the line. It's up to you. You don't have to do this. If I were you, I'd do it. Shit. All right, guys, getting something freaky. Should be. Yeah, don't graph it first. Get that slope first. What are you guys getting for the slope? Yeah, 4 minus 0 over 3 minus 3. 4 over 0. Undefined. Sometimes, has any teacher ever told you that that's infinite?
Yes.
Yes, so infinite slope. If I just said infinite slope to you, what kind of a mountain is that? That's a mountain that just goes up like a rock wall, right? You just climb that sucker, right? No. Okay. So this is also known as infinite, because what happens when you divide something by a smaller number? The result gets bigger, bigger, bigger. So 4 divided by the smallest number should be related to infinity. So there is a relationship there. So if you've only ever called it undefined, you're fine. But it's possible sometimes some teachers could call this infinite. Okay, so now when we graph this should get borne out by the result. 3, 0 is where? Where do I go? 3 on the x-axis. And where's 3, 4?
3 over 4.
Yeah, so there's that infinitely sloped line. This would be basically an impossible graph for a prophet. What this says is, no time is passing and our profit is just rising forever. Yeah, you wish. How much money we got? Infinite amount of money. How the hell do we do that? I don't know. It's a good place to be. No. So this ain't going to work. That's why undefined makes more sense in this undefined situation. Yes?
Can you do A?
Sure. Is everybody cool with B?
Yes, sir.
All right. Go ahead and try A. And then we'll catch up to you in a minute. let's take a look here. Whoop. So, however you chose to label these, so the slope, if I went this way, -1 minus 2, you might have went the other way, doesn't matter. That y minus that y. I better do that x minus that x. And I'm going to get -3 over 6, -1/2. Is that all right? What happened? Everybody okay? No, you might have done 2 minus -1, which is 3, over -5 minus 1, which is -6. It still becomes -1/2. So if I'm going to go graph this, what do I know is going to happen with the line? It should be going... but I mean in general, an overall thing, is it going up or down? It's going down. As I read left to right, it's going down. So if I plot -5, 2, and 1, -1, plop. And then, oh, I don't know, where am I? Oh, here we go. Everybody pray. Hey, not bad. So that is down 3 over 6. But if I go down 1 over 2, bam, I'm on the line. Down 1 over 2, bam, I'm on the line. So if I went down 30 over 60, I'd be on the line again, just way over there. Any multiple of that -1/2, any equivalent fraction of that is another big-ass step I could take to get to another point on the line. Please let that make sense. All right, here's the next level of this, sort of. We're bringing some units in here. Bringing units back. Here we go. Do this. So find the y-intercept. What's y-intercept mean? Where it hits the y-axis. It's a good name. And then find the slope of the line. So they give you a graph, you can find the slope, but interpret the slope. Let's see what happens. You got units now. Oh shit. You got dollars and years. If you ever bought anything in the world and you try to resell it a certain amount of time later, the value depreciates. Cars, the minute you drive them off the lot, oh, it's worth 1,000 less now. Oh shit. So again, I don't have the equation, but I do have the answers to the equation, which kicks ass. So what is the y-intercept numerically? What is it? So numerically, the y-intercept is 0, 9,000. Yeah, whatever, Jeff. But the y-intercept is a point. I really want to make that clear. Because some people are doing x and y-intercepts, so you get the x-intercept of 3, which isn't right. Y-intercept of 7, and then you just plot 3, 7. No. Those are two separate points. 3, 0, and 0, 7. That's why I really want you to always write it as a point. So you don't stick stuff together that shouldn't be stuck. What does it mean, though? So that's what you guys bring in, $9,000. What about $9,000?
The initial value.
Yeah, the initial cost. That's how much I bought it for. The initial value. I like it. So very often, the y-intercept is going to be the initial whatever. The initial position, like that one where I started off at a certain, like 3 feet away. The initial whatever. The initial temperature that the oven's at. Whatever. Now how do you find the slope of the line? Yeah, so take 2 points. You could even use this one. I know that one. That was a nice one. Right? This one and that one? Or you can use this one and that one? Or that one and that one? Sorry, to make fun of somebody yawning. So it doesn't matter. So who used what? Did anybody use these two?
Yes.
Okay, I would think a majority probably would. How much did I go? How much is each step though? You got to be careful. What's the scale here? 900, right? They chose a scale of 900 so they'd be able to graph this thing well. So it would go 900, 1800, 2700, 3600. So it's down 3600, and then over, and then thankfully this scale is in ones, which is nice because it's years. 1, 2, 3, 4. So what is that? What is on top? What's the units on the top? Dollars. And on the bottom it's years. So what do you get when you reduce this? Negative $900 per year. And of course, what does that mean? Pretty much exactly what I just said, but just splayed out a little bit better in the sentence. Every year it loses $900 in value. Yes, are you? Stretching, okay. The stretch has always confused me. Now me, I would have picked this point and that point. It would have been down 1800 over 2. 1800 divided by 2 is still 900. Right? It doesn't matter which point you pick. What does this one mean? What is that point? That is the what? The X-intercept. Just like that's the Y-intercept. This is the X-intercept. What does this mean physically?
After 10 years equals
After 10 years, your computer is worth shit. Right? After 10 years, you basically just give it to somebody. You're not going to sell it. I'm selling this for $3. No, you're not. Give it to me. It's not worth crap. I'll take it away from you for free. There you go. Yay. After that, then you have to pay to get people to take it. No. All right. Is that decent? I mean, there will be some units to consider. But what do you always do? What we just did. When I do the Y's, I put dollars there. Over the X's, years there. And then I know exactly the units.
Isn't it supposed to be $900 1 year?
Yes, totally. But I don't have to write one,
Oh, yeah.
right? So $900 down per year. So you can put a 1 there if you want to, but we know we don't have to. Yeah. Okay. So let me, I want to do something a little out of the book here for a second. And of course, I can do whatever the hell I want to. It's my class. Ha. So, Carrie, can you turn the lights back on? Thank you. All right, I want to do a nifty example here. All right, this is all going to tie in, don't worry. Feels like we're taking a step back. We're going to take a step forward. If I make a little XY table of values, what's a really good number to put in for X? Always.
0.
0. I'm going to put a 0 in, what do I get? Now what if I would have put a -4 here? Well then here I would have gotten a... What if I put a +7 there? Well then here I would have got... 7. And whatever the shit this is, it is the Y-intercept. Whatever number is here. So if I have a 3x plus, I don't know, b we'll call it. We make x 0, what's y? B. So whatever the hell b is, when it's in this form, when it's solved for y, that's the y-intercept. Why? Because that's what you get when you make x 0. How do you find the y-intercept? You make x 0. All right, now watch. Now what if I make x 1? What do I get? 2, that's great. What if I make x 2? 5. X 3. 8. Okay. And now we've done this before, but now we can see this in the context of slope. What's the slope between these 2 points? Yeah, because the bottom is going to be 1, right? 1 minus 0. So every time x changes by 1, y changes by 3. In fact, it kind of makes sense. There's a 3 right there. I call that the amplifier. However much x changes, that amplifies it for y. If x changes by 1, y is going to change by 3 times that. So whatever number that is, it will be the slope. That's so flippin' awesome. I really want you guys to understand. So watch. Let's take one that's not in that form. Let's say we have, there. Not in that form, Jeff. 2x minus y equals 5. It's not in the right form, right? Okay. But when I put 0 in for x, what happens?
0 minus.
So your y is negative 5. Right? And if I put 1 in for x, what do I get? Yeah, I get y equals negative 3. Right? So what's the y-intercept? What's the y-intercept? 0, negative 5. That's the y-intercept. What's the slope? It went up by 2. So if I solve this for y, then it should have a 2 here and a negative 5 here. Let's see if that's true. If I solve this for y, what happens? I can subtract 2x, force that sucker in front to put it in the right format. Divide by negative 1. Y is 2x minus 5. There. The slope is 2. The y-intercept is negative 5. All right, so how is that useful, Jeff? So again, we call this, in general, M. So that is the form of a line. You must know it. That's what's called, math people, we're very creative. So this equation has slope and the y-intercept. What are we going to call it? And we say, slope-intercept. So this is called the slope-intercept form. So word-for-word recreation of the moment they decided what the name would be. Okay, so let's see how this is useful. So if I give you an equation, 3x plus 5y equals 10. Can you put it into that form? Just take a minute, don't say anything out loud. What does it mean to put this into that form? A better way to say that is to solve for y. Solve for y. It's a little bit hard for you to believe that if you solve for y, everything falls into place. The slope falls into place. The y-intercept falls into place. But that's just because it's such a simple relationship. I put it in the right form, I should be able to see stuff about what the graph is going to look like, because the graph is controlled by this. So do it. Go ahead and solve this for y. All right, so what's the first thing to solve this for y? You just subtract 3x. Do you remember a while back I talked about there was that formula section 2.3, I think it is? It is solve for a letter with all these other letters in this equation. And back then I said don't worry about putting this in my order. Now you got to worry about it. You want to force that dude there. Just so it's more in that form, right? So I'm going to write it like this. 5y equals negative 3x, and 10 is positive. See? Yes, ma'am. Anytime you're trying to find the y-intercept, you put a 0 in for x. So if the question would have said, find the x and y-intercept, you would have put a 0 for x to find the y-intercept and a 0 for y to find the x-intercept. My question for this was, put it in that form. And then we're going to see what we can see. Different question. And what's the last step on this? Divide everything by 5. That's the shortcut kind of way to do that. Nobody can escape. You don't get to choose. You do it to both sides, so then both of these get it. So then you get y equals negative 3/5 x plus 2. So now we're finally to the point, become a 3, where Jeff can make a 3. There you go, dude. That's close enough. I'll move on. And I can graph this without making a table of values. We know enough now. So when we hit a new function, we'll make a table of values, we'll learn more about it, and then we'll say, screw table of values. I know this other shit now. I know how to graph this quicker. So with lines, I really just need a point to start at and a direction to go from there. Those two things define a specific line. Start here, go that way. Okay, that's a line, right? And what's the point we normally start at would be the y-intercept. Can somebody tell me what the y-intercept is? Beautiful. Y-intercept is 0, 2, because there's a 2 there. If I make x 0, I'm going to get that. What's the slope? Down 3 over 5, 11, negative 3/5. So what would that look like if I graphed it?